friends. Welcome to Get My Job channel. In today's video, we'll see top 10 questions for cracking electrical engineer's job interview. Topic for today's video is transformer testing. So friends, prepare for the interview for the job of electrical engineer. Let us know top question on transformers which are asked during electrical engineer's job interview. To support your interview preparation, I'll be publishing series of such videos on each aspect of electrical. To get such videos firsthand, please subscribe my channel and press the bell icon. So friends, let us see the typical questions asked on transformer testing. So what is PI test for the transformer? Polarization index test or PI test complement power factor testing. It would definitely be needed if AC power factor test were not to be done. It is a new installation, or transformer is suspected to have damage or moisture contamination. For the PI test, calculate the ratio of 10-minute reading to the 1-minute reading. Good insulation will yield a PI above 2 and below 1 for poor insulation condition. A PI between 1 to 2 is considered marginal. PI values are most useful when 10-minute mega reading is low. When the mega reading is high but the PI is low, the low PI value should be ignored. What is tan delta test of transformers and what is use of it? The objective of this test is to ascertain the general condition of ground and interwinding insulation of transformer. The condition of insulation is essential for secure and reliable operation of your transformer. Measuring capacitance and dissipation or power factor helps you to determine insulation condition in bushing or between windings. Changes in capacitance can, for example, indicate mechanical displacements of winding or partial breakdown in bushings, aging and degradation of the insulation coupled with the increase of water increase the amount of energy that is converted to heat in the insulation. The rate of these losses is measured as a dissipation factor. With our testing system, you can even determine the capacitance and dissipation or power factor at variable frequency. Therefore, aging phenomena can be detected earlier and corresponding action such as repair, oil treatment or drying can be initiated. What is SFRA test for transformer and what is use of it? This is a very reliable and sensitive method or tool for condition monitoring of physical condition of transformer windings. The winding of transformer may be subjected to mechanical stresses during transportation, heavy short circuit faults, transient switching impulses and lightning impulses, etc. These mechanical stresses may cause displacement of transformer windings from their position and may also cause deformation of these windings. Windings collapse in extreme cases such as physical defects eventually lead to an insulation failure or dielectric faults in the winding. Swift frequency response analysis test, or in short SFRA test, can detect efficiently displacement of transformer core, deformation and displacement of winding, faulty core grounds, collapse of partial winding, broken or loose clamp connection, short circuit turns, open winding condition, etc. Typically, SFRA test is called the stamp of the health of the transformer. What is BDV test for transformer oil? The BDV test of transformer oil is the breakdown voltage test used to check the insulation strength of transformer oil. Dielectric strength refers to the maximum ability to withstand the voltage of an insulating oil. This test shows the insulation strength of a transformer oil. BDV of 50 kV and above is considered good for operation, while 60 kV and above means the oil is in excellent condition. When gap between terminal voltage during BDV test is 2.5 mm. This value tests the voltage up to which the oil does not conduct or does not create any spark between the terminals during BDV testing. What is DGA test for the transformer oil? DGA is dissolved gas analysis of the transformer oil. Dissolved gas analysis is the study of dissolved gases in the transformer oil. It is also referred to as a DGA test. Whenever a transformer undergoes abnormal thermal and electrical stresses, certain gases are produced due to decomposition of the transformer oil. What are different gases tested in DGA and what they indicate? Different gases tested in DGA are as below. These gases above specified limit will indicate the fault in transformer, like methane and ethane. Higher number of methane and ethane indicates gradual overheating. CO or CO2 or both. Higher than a specified value of CO2 indicates transformer overloaded or operating hot. Ethylene. Higher value of ethylene than the specified value indicates hot spots in the overheated joints, core boards, etc. Carbon monoxide. Higher value of carbon monoxide than the specified value indicates overheating involving cellulose insulation. Hydrogen. Higher value of hydrogen than the specified limit shows corona discharge or electrolysis of water or rusting inside the transformer. Hydrogen, CO2 or CO. Higher level of hydrogen, CO2 or CO than the specified limit indicates corona discharge involving cellulose or severe overloading. What is Furan analysis for transformer and what's its use? The testing technique developed where we can examine the condition of paper insulation without touching it. The method is called Furan analysis. Furan analysis is a very sensitive as damage to a few grams of the paper is noticeable in the transformer oil, even in a large transformer. It is very significant diagnostic test and is generally considered the best test for assessing the life of transformer. The percentage rate rise of perfluorous products in the transformer oil over the time is used to assess the condition and remaining life of the paper insulation in transformer. What are the types of current transformers? According to its magnetic circuit, there are three types of current transformer commonly used in power systems. These are ring type CT, core type CT and shell type CT. What is the burden of CT or current transformer? The burden of CT is the maximum load in VA that can be applied to the secondary of CT. It can be expressed in two ways. The burden is expressed as total impedance in ohm of the circuit. It can also be expressed as total volt ampere and power factor at a certain value of voltage or current and frequency. Why the secondary terminal of CT should not be left open circuited? In current transformer, the primary current does not depend on the secondary load of CT. It purely depends on the line current where it is connected in series. If the secondary winding of CT is kept open, then secondary current will be zero while the primary current of the CT will remain the same. Therefore, the opposing MMF in the secondary winding will no more exist. Hence, net MMF due to primary current only, which is very large. This large MMF will produce huge flux in the core of CT. Hence, it will saturate the core of CT. Again, due to huge flux in the core, the flux linkage of secondary winding will be large, which in turn will produce a very large amount of voltage across the secondary terminal of the CT. Hence, the large voltage across the secondary of CT will be very dangerous, which will lead to an insulation failure. There is a chance that if the person who is operating the secondary winding of the CT where primary is energized will die due to electrical shock. What is knee point voltage of a CT? Knee point voltage of CT is defined as the amount of voltage at which a 10% increase in secondary voltage of CT results in 50% increase in its excitation current. The knee point indicates the saturation point of CT on BH curve or the magnetization curve. Above the knee point voltage, the CT gets saturated. The knee point voltage is an important parameter for the selection of CT for a particular electrical installation. What is the effect of saturation on the performance of CT? The increase in excitation current of CT causes the reduction in the secondary output, which reduces the speed of overcurrent relays. The saturation of CT also disturbs the balance in the differential relays, thus affecting the stability of protection. Therefore, the effect of saturation makes the operation of CT unsatisfactory. What are the pre-commissioning checks required for a transformer? Following tests are required to be done as a pre-commissioning checks for the transformers. Core insulation test, operational checks for protection system, IR measurement, tan delta measurement of bushings, tan delta measurement of windings, turn ratio measurement, vector group and polarity, winding resistance test, magnetic balance test, floating neutral point measurement, measurement of short circuit impedance, exciting or magnetizing current measurement, vibration measurement of oil immerse reactor or transformer, operational checks of OLTCs, stability of differential or REF of the transformer, test and checks of bushing current transformer, frequency response measurement, DGA of the oil, and IR thermography. To know about each test, watch the next video. What are the checks to be done after receipt of transformer at site? Nitrogen pressure and dew point to be checked after receipt of transformer at site. It should be within the permissible band. The data of impact recorder shall be analyzed jointly in association with manufacturer. Impact recorder should be detached from the transformer, preferably when the main unit has been placed on its foundation. Oil samples should be taken from oil drums or tanker received at site and sent to the dedicated lab for oil parameter testing. The copy of test certificate of routine testing at oil refinery should be available at site for comparison of test results. Unpacking and inspection of accessories to be carried out with all precautions so that the tools used for opening do not cause damage to the contents. Fragile instruments like oil gauge, oil level gauge, temperature indicators, etc. are to be inspected for breakage or other damages. Core insulation test shall be carried out to check insulation between core and ground. After receiving the accessories at site, same should be inspected and kept ready for immediate erection. If erection work cannot start immediately due to some reasons, the accessories should be repacked into their own crates properly and packing list should be retained. If the transformer is to be stored up to 3 months after arrival at site, it can be stored with nitrogen filled condition. Nitrogen pressure to be monitored on daily basis so that chances of exposure of active part to the atmosphere are avoided. During erection, the exposure of active parts of transformer should be minimized. Further, either dry air generator should be running all the time or dry air cylinders may be used to minimize increase of moisture. In case of drop in pressure, dew point of nitrogen has to be measured to check the dryness of the transformer. So friends, I hope this information was useful for you and you will take advantage of it. Please like and subscribe my YouTube channel for more such videos. Thank you friends.